Welcome to today's KMWorld webinar brought to you by Verint, SDL, and Northern Light. I'm Mary D. Ojala, Conference Program Director, Information Today, Inc., and I will be the moderator for today's broadcast. Our presentation today is titled Harnessing Cognitive Computing and AI. And now to introduce our speakers for today. John Schmay, Senior Director, Product Strategy, Knowledge Management, Verint. Jane Hendricks, Senior Product Marketing Manager, SDL. And David Seuss, CEO, Northern Light.
Thank you, Mary D. And John and Jane, you have set a very high bar in your presentations. I found them riveting, and hopefully I will do as good a job as the two of you have done. So by way of introduction, Northern Light serves large global organizations that are in many industries. Our clients tend to have tens of thousands of employees. They often spend between 10 and 150 million a year on market research and competitive intelligence, particularly when it's internal market research. The budgets can get very large. And we average over 8,000 users per client. And across our entire network, we have 250,000 user accounts. On any given day, we see 100,000 search queries for market research and competitive intelligence. And this gives us a very good view into what is happening with users of that kind of content. And so what are we hearing from our users? We're hearing things like these. I hate the search process. Now, what's being referred to here is not, Google search, where I'm trying to find out what the Red Sox score was last night, or going to Amazon and looking up umbrellas because I'm traveling to Seattle soon. What they're talking about is the business search process, where a person needs to learn, master a new topic, needs to understand something they don't understand. They don't know what the questions are. They might not recognize what a good answer is. And the business search process is viewed as tedious and laborious. It brings back long search results with lots of documents on it. And what do you do with that document list? So users are telling us, I hate the search process. They're also telling us, why do I have to read all those reports and articles on the search result? Why can't the search engine just read them for me and tell me what it finds? And why do I have to search at all? Why can't the search engine just watch the content flow and tell me when there's something new I should know about? And all of these things are about time. It's about the modern work environment where we're stretched too thin. We have too many tasks. We have too many interruptions. And there's too much material coming at us from too many different directions. Search has never really been able to address these kinds of questions until recently. And it's because to accomplish the above, search has to be able to distinguish not just what is relevant, but also what is important. Search engines have been good for decades at calculating statistical relevance, but we never had the ability until recently to address the issue of importance. So let me illustrate this with a real example. Let's say I'm a marketing manager and I would like to learn about how to use sustainability marketing and focusing on millennials as a market segment. So I do a query against the news. I'm looking for trends against the news database. And my query is sustainability marketing to millennials. On the left-hand side here, you see the traditional search result, which gives us a relevance rank set of hits, a little snippet of text from which you're supposed to determine if this is a good document for you to drill into and read. And that's traditional search. I also have 711 hits, which is sort of the overwhelming response that any robust search engine will give you against a large content collection for almost any query. And we sort of leave it to the user to slog through that search result and figure out which documents to download and to actually read. Now on the right-hand side, I'm hiding something from you. And I will now do the big reveal. So what we see here is the Insights report. And in the Insights report, the search engine has read the documents on the left-hand side and has found the important ideas and has written a report for the user to read and consume as an alternative to just consuming the traditional search results on the left-hand side. Now I'm going to expand this report for you to make it easier for us to read and see if we can learn anything about sustainability marketing to millennials from the Insights report. So let's take a look. On this first hit, we're seeing we believe these trends will make permanent impacts on the future of the food and beverage packaging. So packaging is introduced here as a concept. Millennials have taken the lead on sustainability packaging conversion with the expectation that brand owners would do their part to deliver eco-friendly solutions. Let's go down to the next item here, which happens to be from Forbes. But the question has always remained about whether the cost of implementing models to make products more sustainable was actually, well, sustainable. And it goes on to talk about how the millennial generation is willing to pay more, as indicated, for sustainable goods. So we've already had two insights here from our Insights report, that packaging is related to sustainability marketing to millennials, and that there's an issue around cost and economics and premium pricing and whether or not that will work for the consumers. And we could go on and read the rest of the report. It's about 40 sentences in total. This is just an excerpt. And we would gain many marketing insights into our question without actually yet downloading a document and reading it. The Insights report is produced by the machine learning algorithms, and what the algorithms do is they identify the most important ideas in the documents, and then they write the report. And each idea fights for its position on the report. It is scored based on how pithy, relevant, and important it is. Next, there we go. I was having trouble getting to the next slide, but now we're good. So we do this by calculating a semantic graph. The actual graph is a table of numbers, but I have illustrated here how it works. And I've taken 5 sentences from the documents on our search result. These are all from different documents. The graph looks for relationships between the ideas and sentences. And the principle behind the semantic graph is the most important items are those that have the most relationships with the most important relationship partners around the most important topics. So the AI uses the semantic graph to find the important ideas. And let's take an example here. In this first sentence from one of the documents, we get millennials and sustainability and they're willing to spend more. And that relates to this sentence from a different document, which gives us millennials and sustainability and a willingness to pay more. Those are 3 overlapping ideas between these 2 sentences. This is a very strong relationship. If we take the sentence here sort of in the middle, millennials have taken the lead on sustainability packaging conversion. There we have millennials and sustainability, which has 2 relationships with each of those other 2 highly related sentences. So not quite as related, but strongly related. On the bottom left-hand side, we see the consumer increasingly cares about sustainability. Here we get sustainability as a concept that relates to each of the other items, each of the other 3 there. But you don't have millennials in that sentence, and you don't have packaging, and you don't have product pricing or costs, and so it's weakly related, but it is related. So those 4 actually all made the cut, and they got into the Insights report. On the bottom right-hand side, we see that there's the really good sentence in a different context. Live music events are the ultimate playground for beauty, inspiration, experimentation, etc. But we don't get millennials, we don't get sustainability, and we don't get packaging, and we don't get willingness to pay more. So that sentence doesn't make the cut. It doesn't get into the Insights report. So the Insights report consumes the text, all of the text on the documents, calculates the semantic graph, finds the important ideas, and then writes the report. It is a breakthrough in how to interact with a search result. The machine tells you what it reads the reports and tells you what it finds. There are many benefits to this. The average occasional user will be better informed about the business issue if the user reads the insights report than if the user engages in the traditional search process. Users, on average, only download one document per search, at least the occasional users. The marketing managers, the product managers, the people who aren't in market research or competitive intelligence. And that means that they miss the insights from all the documents that they don't read on that search result. With the insights report, all of the documents have a chance of contributing important ideas to the report, and the user is much better informed than following the traditional search process. And the point is to inform users better. Now, power users are different. They drill into topics and they read multiple reports and articles. And for them, the insights report gives them a quick and easy overview of the issues, alerts them to the themes. And so when they go back to that traditional search result, they are very well informed about the topics, and they can consume that traditional search result much more effectively and efficiently, find a lot more material. Interestingly enough, if you think about we're writing a report for the user instead of the user having to read the documents, you might think it depresses the number of documents downloaded. It actually doesn't. We've seen an across-the-board increase in the amount of content that is downloaded by users with the Insights report, because when you find more interesting things, you just want to read more about it. And so we're informing users that they are, we're informing users better, and they're finding better material. Now, the other thing, if you remember, was a comment that users, why do I have to search at all? And why can't the machine just monitor the content flow for me and start proactively delivering content to me? We do that with personalized recommendations, also based on machine learning. We basically build a model of what every user is interested in. We have 250,000 users. We have 250,000 models. The machine watches what people download, builds a topic model for that user, and then starts monitoring the content flow. And in this case, the machine has noticed that David is interested in sustainability marketing, and it's starting to proactively recommend content to me so that I don't even have to look for it. I can rate the recommendations, and the model adjusts to my feedback and gets better and better, knows more and more about what I am interested in, and gets more effective at recommending content to me. We do this with a technique called latent semantic indexing, where you can think of it as the example here. This user 1 has an interest in millennials and sustainability. It's pretty balanced. This document 2 discusses a mixture of both sustainability and millennials, whereas document 3 only really is about millennials. Document 2 is closer to what the user 1 cares about and might get recommended to the user, and then whereas document 3 would not be. Now, in actual practice, these aren't single words. These are groups of words that like to hang out together and which represent topics. So it includes synonyms and related terms. And the machine figures out what the topics are. It's all unsupervised learning. And we also use 800 dimensions. We don't use 2. And so the recommendations tend to be eerily on point for the users. That's the feedback we've gotten. It was like, wow, these are better recommendations than I could find with my own search queries. So what type of business content does these 2 machine learning techniques work for? All textual formats. We've used it successfully on every format. We've used it on primary market research, syndicated market research, competitive intelligence, business and technology news, technical journal articles, and conference presentation. It really works across the board. The more a document is about something, the better it works. In conclusion, I'd just like to comment on what we see in the future. We think we're approaching the end of search. We're approaching the era when users will no longer search for information. They will expect the machine to find what they need on its own, and they will expect the machine to summarize for them what they need to know. This is a sea change. This is profound. This is a moment of discontinuity, and it's happening right now. Search is evolving to have an in-depth understanding of the search material and the ways of knowing in the user's domain in order to interpret the content. You need to understand how users think about it, and then the machine needs to learn how to do that. Using machine learning, search is now able to distinguish not just what is relevant, but also what is important, and to summarize the important ideas in a document, across documents and across sources, and learn what the user cares about and find relevant material without being asked. I'd like to leave you with this last thought. The impact of these machine learning trends on the socialization and utilization of market research and competitive intelligence in your company will be profound and will change everything you are doing in your knowledge management system.
David, you talked a lot about machine learning. Do you want to add something into this discussion?
Well, I think practitioners universally prefer the word machine learning over the phrase AI. And the reason for that is we know what machine learning is. As Jane said, machine learning is a set of algorithms for teaching a machine something. And, you know, if there's a teaching process going on, there has to be a teacher. And the teacher, in the case of machine learning, is the human being who understands the subject matter and knows how to teach the machine. So whereas AI is this almost consumer marketing idea, it's a media concept. I don't know what artificial intelligence is, and no one else does either. And I don't think it exists as a practitioner, but we're driven by the marketing requirement to use the phrase AI. And so, you know, machine learning, talk to me about machine learning. We can discuss algorithms, techniques. Tell me your problem, I can tell you what the technique is that will solve it. Talk to me about AI, and I feel like I'm in the land of science fiction. So I don't believe in linguistic AI. I believe in linguistic machine learning.
Linguistic machine learning, okay. Well, what was the hardest part in using machine learning for the text-based business reports you were talking about?
Well, that would be data preparation. Data preparation consumes 90% of the CPU cycles. In our case, we have to part-of-speech tag every word. We have to parse every sentence, identify not only what the nouns and verbs are, and adverbs and prepositions, but what the noun subjects are and the predicate verbs. You have to identify those sentences that contain pithy ideas, and so there's a lot of processing to do that. And I went to a seminar at Google. We use a lot of Google machine learning algorithms, and the first bullet point on the first slide of the first speaker from Google was that 90% of projects fail at the data preparation stage. So that is really the hard part. When you talk about indexing for search, it seems like that's a big process. We always thought search was CPU intensive. Machine learning, particularly the data preparation cycles, are 5 to 10 times more CPU intensive than simple search. So it's data preparation is the hard part.